Hey, everybody. Super excited to be here and demo and talk about a few very interesting ideas that we've been working on. Um, but uh, but 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 really to kind of have a conversation with all of y'all and our team here in kind of thinking about what how data and APIs need to change to make sure that AI and the next generation of AI applications can really connect to it in real time. And so that's uh, that's what we're going to be talking about. And with that, let me just introduce myself and Abhinav, who's also here. I'm Tanmai. I'm the CEO co-founder at Hasura. Started Hasura a few years ago to with the idea that applications and front-end applications really need access to data, and especially real-time data, live data, so that they can do useful things. Um, and and over the last few years, all of the work that we've been doing has given us a phenomenal amount of insight into what the actual challenges in harsh conditions and real world conditions are with being able to use that data in applications. And a few years ago, as AI started to really pick up, we started spending our time thinking about what it would mean and what the challenges are in trying to get data and real-time data connected to AI. I'm going to define these things in a bit, but before I do, I'll just hand it off to Abhinav for a quick introduction.
Hey folks, very excited to be here. I'm Abhinav. I am working in engineering at Hasura. Been driving this uh, Pacha AI at Hasura, and before this, I used to work at Google, also doing similar things. I was at Google Assistant for a few years in Google Search, and so kind of seen the space evolve and really explode and go crazy over the last couple of years. Yeah, and I'm sure we'll dive into a lot of it.
Awesome. And so yeah, that's Abhinav, me, and a lot of folks at Hasura have been kind of working on stuff and talking to customers and kind of gathering insights and understanding really kind of what the challenges are. And so with that, let's just kind of talk about set kind of the stage up for what really is happening with real-time data and kind of getting access to stuff, right? So uh, let's talk first a little bit about what I mean by real-time data, right? So for some of you who might be, if you're building kind of apps and mobile apps and stuff like that, right? If oftentimes we think of real-time data as data that is, being streamed, uh, like it's live on the app, but it's refreshing continuously. But what we mean by real-time data here is not just that, but we also mean data being able to access and use data as soon as it is created. So these are typically transactional. This is like transactional data, right? So this is SaaS data, or this is your product data that's in your a technology product that you've been building, or you're getting customer information and you're able to use that customer information instantaneously, at the time of creation, right? Like right after the time of creation. And that's kind of what we mean by real-time data here, right? What this doesn't include is, for example, or what we're not talking about here is, for example, analytical data. I mean, we, we'll talk about analytical data, but really we believe that the key unlock over the next few years is going to be with real-time data, right? Um, and just to kind of tee that in, right? When we think about real-time data, it's like when you have applications and they were not AI, just mobile apps or web apps or internal applications or whatever you had, right? These applications were phenomenally useful because we could actually do stuff with it, right? Like you place an order, right? You browse products that are currently there. If you're looking at customer support tickets that exist and you're responding to tickets, right? So that application is talking to real-time data. It's talking to real-time data that's coming from multiple data sources, right? Not just one database. And this is a simplified view of what happens for normal applications, right? You have a product experience, you have a backend thing, and then you have a database thing. And of course, in reality, this is a lot more complicated. This backend is probably something like an API gateway with multiple microservices, and this database is not just one database, it's probably several different databases connected to different microservices or what have you, right? But ultimately, at a high level, this is kind of the way that we think about our layered stack, right? And so, really, the question that we're exploring and the claim that we're making is that if these applications, instead of being applications on your phone or on your desktop or on your laptop. Um, I said on your desktop. I don't know how many of us use a desktop anymore. But if these are going to be AI applications, and by that I mean say assistants or agents today, but in the future these could be all kinds of AI applications, right? Like it could be robots, or it could be inside embedded devices, right? These AI applications, they will also need to kind of talk to data, and just like we did not give direct access to our data stores, and we had a layer of abstraction that allowed us to present and operate our data for applications. We need to do something similar for AI, but for these AI applications. But what is it? What do we need to do? And kind of what is the state of affairs today, right? So the first claim, in kind of unpacking that a little bit, right, to understand that, let's take a look at what actually goes inside a backend, right? So uh, inside this kind of middle box here, right, you're doing data retrieval, you're doing transactions, right? You're doing authorization stuff, right? You're doing orchestration logic, and you're doing presentation logic, right? So hopefully that's familiar. These concepts sound familiar to you folks who've been kind of who've been around the block a few times, and you've seen kind of what all goes into this space, right? Where the idea is that you've got to fetch data, you have core business methods, right? Like transfer money from person A to person B, right? Or do a really custom retrieval, right? And those are kind of like more transactions or methods that you have. Of course, you have authorization and validation for both reads and writes. And then you have a lot of orchestration logic and presentation logic. And this is the piece that's kind of interesting, because as we start to think about AI applications, right? These are the two bits that become pretty unnecessary, right? This is kind of what gets and here's in the way. So let's unpack that a little bit, right? So uh, AI assistants and agents are not uh, are are smarter clients than an application-based client. And because it is a smarter client, it is going to do the orchestration on the fly, and it is going to figure out what kind of presentation is required with that on the fly, right? I think at this point we've all heard of malleable UI and malleable software and associated ideas where the AI is kind of rendering the right kind of UI for us on the fly, right? Or maybe a UI isn't even required, right? Maybe we're using some of these applications entirely in voice mode in the future or whatever. These are the pieces that kind of are not required, right? But these are pieces that are still core to a business or a domain, right? This is the actual data of the domain that is centralized data. For example, if you're a bank, these are your actual bank accounts. These are the actual business methods in a bank that transfer money from one account to another. That logic cannot go away, right? So even in the future, if I have a bank app and I talk to it on voice and I say, settle my bills for that are less than $100 from the last month, I just want that to work, right? And for doing that, it is critical that these are encapsulations that are provided, but these are bits that probably going to be unnecessary when it comes to AI applications. Um, I think as we kind of started to examine the space over the last year, one of the things that we realized was um, we need something better than API endpoints, because just working with API endpoints isn't working, right? Like if you try to build an application today that literally does this and you connect it to your API server and then you expect it to do a bunch of things, right? Like imagine just replacing this, providing your entire API schema to an AI assistant, and then just using the AI assistant to do stuff. And then obviously it doesn't work, right? And it kind of feels like it ought to work, but it doesn't work, right? And let's kind of talk about why and what those challenges are, and to kind of really get into this idea that this claim that we're making, that it's the way that we've been doing data and APIs and our architecture is entirely is flipped. It's the other way around. It just doesn't work for the way that we're going to be building AI applications or what they need, right? So if you've been building stuff and you've been connecting your AI assistants or agents or LLMs and giving them access to your API schema, uh, you would have noticed that hallucination happens, and hallucination sucks. And it almost feels to me that it's set up for failure. Hallucination is uh, uh, quote unquote inevitable with these endpoints, right? And I'm going to talk about a few of these, and we'll unpack it together a little bit with Abhinav on each of these points, right? So there is a tremendous amount of um, diversity of our API designs, right? It's not common or structured. All of us have different APIs. They all mean absolutely custom things, and uh, and and we hope that we can provide enough context uh, for some kind of on-the-fly learning to happen with an LLM to be able to understand our API design and be able to use it effectively. Um, Abhinav, anything you want to kind of add onto that or onto some of these points in where where these kind of hallucinations kind of happen and what kind of the intuition is behind why some of these hallucinations are almost inevitable when we're kind of working with API schemas and stuff.
Yeah, so if I were to like ask you to go to Postman and start like interacting with your data using Postman, and I time boxed you that hey, you have an SLA that you have to respond in. You're just like the best you were gonna do is like let me try to guess what the parameters are and what they do, because I need to like get a response going, and that's kind of where LLMs are also coming from. But like if I asked you to do something in your UX in the front end application, or I asked you to go to the database console and say just get me this data like from your database console, you would do just like a much better job. You were like, okay, I know what SQL query to write. I don't have to deal with this API endpoint. And so um, the same is also like applying for LLMs. Like APIs were like meant for a particular use case, for a particular like a very evolving set of use cases on your front end application, and like you could take like a lot of time wiring that up and getting that right, which is like not the time we have with LLMs. Like you make sufficiently complicated LLMs, you give them like enough time, they will do it with the API endpoints also. But like at the end of the day, you want like a time box response. So you want to make it like you can't have it both ways. Like do something completely complicated, but do it fast and do it right. Like you can't have like all of these.
Got it. Got it. No, I think that intuition makes a lot of sense, right? And um, uh, i- i- if you think about kind of like some of these areas where it becomes challenging for humans to to figure out what the API is doing, it's it, it gets worse, right? So you have like API designs that are not consistent, and now imagine that it's not one service with 5 API endpoints, but there's 20 microservices, and you want to use some of the API endpoints from these different microservices, and they all have absolutely completely different designs, right? API parameters have often kind of been designed with the idea that there's a lot of tribal knowledge often, right? With API services, it feels like it's like, look, we're documenting the API and stuff like that, especially internally. And there's tribal knowledge on like how these APIs are kind of chained together, for example, right? There's no explicit relationships. There's, it's implicit, right? Like sometimes you have links, for example, in an open API schema, and GraphQL tries to kind of bridge those gaps between relationships. But most APIs, we don't really have relationships between entities, right? We might know how to chain API endpoints together, but at an entity level, we're not able to kind of understand how things are related. So the sprawl that we all have in our organizations and with real world applications, it just makes this worse, right? Like to Abhinav's point of like you just given a bunch of APIs and you're asked to do something in a time boxed way, or you have to respond to me, right? Like I asked you to respond to me and to give me a result. You're going to try to you're going to end up making things up, especially if I've put too much. I'm expecting you to pay attention to a really large amount of context, right? Things get worse with nested and complex data structures. Error codes and messages also vary widely, right? And which I think has an implication on trying to kind of autocorrect or self-heal, right? Because I don't think APIs, um, sometimes really good public APIs are, but oftentimes it feels like APIs are not really designed for an error message in an API doesn't tell you what to do next, right? Like it's not apparent what the problem is or what I can do to fix the problem. Oftentimes API endpoints errors are opaque, right? And we try to, and sometimes it's a design thing as well, right? To make it as opaque as possible, to not leak information about the rest of the API schema or something like that, right? So you want to kind of like say, hey, you're unauthorized or you can't do something, and then it just stops. And there is no way to deal with that as a human to figure out, oops, this is what I'm screwing up and this is what I should make better. Good it takes a lot of effort to design an API where the error codes and messages are so standardized that a human being, while using the API, knows kind of what to do and how to proceed. Um, but those kind of feel like some of the challenges that inevitably lead to um, hallucination or inaccuracy when we're trying to kind of work with API endpoints. Um, uh, Abhinav, anything you want to add to those points?
Yeah, yeah, that covers it pretty well. Yeah, like one thing I would like reiterate is that like API endpoints like were inherently never meant for like actual consumption in like a generic way. Like they were always meant for tied to be tied to a particular use case. Hey, this particular feature in this particular application wants this kind of data, so we'll create an API endpoint for them. And like nobody apart from the person who wrote that feature really even knows like what's happening. So like kind of APIs are like something that we have today, and that's why we have sort of naturally gravitated towards like let's give APIs to LLMs and see what happens. Let's build function calling, tool calling, which has the same signature just because we have APIs today. But it was like never meant for that. Like it's like not a good fit for it at all.
Oh, makes sense. And I think like to your point earlier, right? Like we are talking about like you can kind of make it work, but it almost feels like the amount of effort to make an existing API schema work, right? It's quite untenable, right? Like you have to have really high quality documentation for each API endpoint, and not only do you have to write it for the first time, but you have to keep maintaining it every time the API changes. And God forbid the API just wasn't designed well in the first place. No amount of documentation sometimes is going to cover for that, right? Or I mean, maybe it can if you add examples and then you have to maintain those examples, right? Because if you screw up those examples, then um, then that's a problem as well, right? So those kinds of um, those kinds of issues can kind of start to happen. Um, Sorry, give me a second. Yeah. Um, I think I think it also gets worse when we like the more documentation you have and the more examples that you have for each API endpoint, then the larger number of API endpoints you have, you're going to kind of like start hitting like context window limitations, right? And it's not really just a context window limitation that's a hard limit. It feels like context windows are a kind of a soft limit, right? Is it Abhinav, what's kind of your sense on the context window stuff, right? It's not, if for example Anthropic says that they have like 200K or Gemini says they have 2 million, does it mean that that amount of context window is actually feasible to use, or like how do we think about like how much you can kind of really push this context window length of an LM?
Yeah, I think like it's like very apparent from like a lot of benchmarks that as you start putting more and more things in LLM's context, performance starts degrading. Around like 32K seems to be like the sweet spot for like modern LLMs where things are degrading. Um, but like sure that that might like improve somewhat over time, but like context will always be an issue, right? Like so I think of LLMs as like more like humans and less like software. And like there are humans who can process a lot of information at once. There are humans who don't process that much, but like there is a limit. Like no human wants like just a million things told to them at once and then um, like be able to like make sense out of it. And so like context will always be an issue. Like even where like sure you can like take a million tokens and code them. Like yes, we can do that math, but it's not actually going to result in like all that million tokens being as useful. Like every token is now like proportionally less useful for the LLM.
Correct. And although like I think techniques to improve the context window are emerging, and I hope that over time it becomes practically kind of infinite in the way that it kind of practically becomes like a human, right? Like you don't kind of worry about context lengths that human beings have when you talk to them. And hopefully that's what it gets to, right? Like you don't have to like you build a better and more stable intuition for what the LM can do. But today, and at least it seems like for the next few years, we're going to be in a place where our only way of understanding what the context window length that's suitable is to go through evals and feedback and to have continuous iterations, um, on the evals or with user feedback, and then use that to go back and improve our documentation or add, maintain more examples, right? But to me, kind of this approach feels untenable and has been untenable, right? Like initial stuff that we were building out a year and a half ago or so was just it's just not feeling good, right? And even now, like there are cases where it just hallucinates and it's painful to fix, and even for the human to kind of evaluate and verify what the LLM is doing is challenging, right? Like um it's painful. One of these ideas that we started exploring a while ago was the idea of a query language instead of an API schema. And I think that's been a fascinating exploration and has yielded some amazing results. And we'll do a few demos towards the end and talk about kind of what that looks like. But I think I think the LLMs are really good at generating uh, accurate queries in a language, right? Um, so because that's what it does with English, right? And so the idea is, what if instead of using REST, GraphQL, gRPC, SOAP, etc., like APIs, which have entirely custom grammars. What if we switched over to using a query language instead? So, for example, and when I say query language and we talk about real-time data and we talk about transactions, of course, SQL comes to mind. And so think of SQL as a query language that provides a CRUD or a CQRS API to the domain, right? I just want to be very clear here in for the purposes of this conversation when we say query language, and especially as we take examples with SQL, it's really important to kind of understand one, that we're not talking about SQL here for BI. We're not talking about doing complex SQL, text to SQL to do analysis on the fly, right? Like this is not replacing BI and let's do BI in natural language. That's not what we're talking about. That's a very different use case. We're also not talking about the underlying database. We could be NoSQL, could be SQL, could be not a database, could be SaaS, could be API, could just be data, right? Like we're not talking about the underlying database as well. We're talking about SQL as an as a CRUD API or as a command and uh, query API to the domain, right? We're not talking about SQL as the database engine, right? Um, and just so that we can map it, because I think sometimes this idea is new to folks who I think it's probably not new to folks, to everybody who did to all of us who worked with databases before web apps became a thing where we put a lot of business logic in the database, right? Um, uh, Custom methods are inevitable. There are transactions that are going to happen. You can't, like, what does a SQL API look like for a bank transaction, right? And there is actually a SQL API for a bank transaction that you can create, which is a stored proc, right? So you have a transact method. So you still have custom methods and transactions that are necessary. These are core methods that need to exist, but they can be exposed on a SQL API as procedures, right? If you thought about it from a CQRS point of view, commands, right, would be you'd expose commands as SQL procs or SQL functions. That's what the SQL API will look like. But again, we're not kind of talking about direct access to the database, or we're not even commenting on the database here at this point, or we're not even talking about BI. But but if we took this thought, right, which is interesting, hard, because like how SQL API for like web APIs using my mobile apps are going to talk to in SQL to my microservices. That's kind of interesting. Uh, we've not thought about it that way, but if we push that thought a little bit, right? And again, just to make it more concrete, like let's say you're like weather.com, instead of having an API for weather.com, what we're really talking about is a current weather table where you can just select star from with predicates, right? So we're talking about kind of this idea to expose the API instead of this REST API, but we're still talking about the weather.com domain. We don't even know what the underlying database here is. We don't even care. Um, but what happens if we start to kind of think about it from this point of view, right? Um, and 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 what we started noticing was that there was a dramatic reduction uh, in in hallucination and our ability to reason about what was happening when we started using a query language. And it feels like the reason why that was starting to happen was because, you know, SQL's been LLMs have been trained on SQL. It feels like SQL's been around for 40 years, and it almost feels like the LLMs, modern LLMs, know SQL like they know English. And I think the analogy to English is interesting because English is not a perfect language, right? Like for um, English kind of sucks. It's like it's very confusing. Like compared to it, any other language that you learn, it's not a good language, but it's the closest thing to universal language, right? So regardless of the merits of the language, the fact that it is the most spoken language in the world, either as a first language and a second language and third language, right? It just gives English a fundamentally unfair advantage, right? It's just fundamentally unfair advantage for English that it gets because it's just there everywhere. And it feels like SQL just has that because it's been around for so long that LMs have gotten trained on it, right? And that's kind of it to me feels like why um, LLMs just seem to do much better at being able to generate simple SQL to do stuff. Abhinav, what's kind of your take on on this thought?
Yeah, I think more generally, what SQL gives you, or like a standardized query language gives you, is like two things, right? So when you have your APIs, they capture your data models in some form, like some loose shape. They're capturing your data model, and they also capture how you query that data. Like there's like an implicit query language in your APIs as well, and SQL comes and standardizes a lot of that, and then just the only thing that changes from one SQL query or one SQL schema to another is only your data model. It's not changing like what are my parameters that I can take, how do I query, is this how you filter things based on timestamp? What does a timestamp even mean? Is it a Unix epoch does it take, or is it an ISO timestamp? What about time zones? Does it handle that? Like so, like all of these questions are like don't exist anymore and don't vary from schema to schema because we standardize everything in one single query language. Now we could have picked another query language. Like SQL is like not the only option, but like why reinvent the wheel, right? SQL has been around for 40 years. It still exists. It's still going strong. It works. LLMs are great at SQL. So yeah, um, it's like
No,
basically
makes
the fundamental idea is the query language, and SQL is like the best choice there.
the best, a good choice for query. But hypothetically, we would notice the same benefits also if you took a LLM and you trained it really on a structured query language, SQL. But if you trained it on a query language like SQL, like any language, it doesn't matter, we could potentially start to see the same benefits, right? Because I guess what we're essentially able to do is we're able to encode the semantics of our API a little better inside the LLM itself, right? And we're able to standardize certain things and make sure that the degrees of freedom are a lot more restricted, kind of like a language, right? But even more. And that's the benefit that we're getting. But whatever we're kind of talking about here works with any query language and that you could train the LLM on, except that if you just don't want to do the work, LLMs have already been trained on it, right? And at this point feels like anything that you do with an LLM will anyway not be valid in 3 or 4 months. So there's that too. Um, I think I think there's another kind of interesting point on the maintenance and the governance side of things as well, right? Which is that entities are much more easier to kind of govern compared to endpoints, right? Like I feel like entities are a natural unit of the business, whereas endpoints are a natural unit of the product, to what Abhinav was saying earlier, right? Where an API endpoint was designed to power a button click thing, right? Um, Public APIs, I think, are at a really nice kind of middle ground between these two. But with most internal APIs, for example, endpoints have been kind of working backwards from a particular product requirement, a very specific, valuable interaction, right? But they're not really necessarily units of the business, right? Like a bank would not describe itself uh, via its API, as much as we would like it to do so, and as much as its public API ought to do so, the bank would still describe itself in concepts of its entities, right? And these entities are much more easy to kind of document or keep updated, right? these entities are easier to secure, and you can add authorization rules around those entities, right? So for example, an entity, if you think about it as an object, you can authorize that object, and you can have conditions to access that object or not access that object, or fields in that object and stuff like that, which is harder to do with an endpoint uh, because if you can secure the object regardless of how it is accessed, that's amazing. But you can't really secure an endpoint. I mean, you can. It just takes a lot more work because each endpoint can access so many different things, right? Um, and so I think that kind of causes like, uh, there's ease of kind of governance that really comes in when we start to think about entities, right? And then if you have a query language on those entities, that's an interesting way to think about an API as opposed to API endpoints that encapsulate a lot of stuff that are expensive to govern that then expose a fixed schema. Um, in kind of terms of this maintenance and iteration, when it kind of comes to this entity plus query language kind of way of thinking about things versus API endpoints, um, any kind of any takes that you have here, Abhinav?
Uh, yeah, so like one of the fundamental reasons why like APIs even existed is to like put Oddsy into the picture, right? Like I can't give you access to my data directly. I need to have a layer in between. And again, like I said, like earlier, like we built it for this particular use case. We had some notion in mind of who's going to access it, how they're going to access it, what are the right safeguards to put in the API, and like where the data is coming from, what is it flowing. Like you know it in the context of that particular use case, but the moment you try to like look at these more generally, it just becomes like impossible to keep track of things. Uh, and like it is actually like sort of much harder than it intuitively feels like it should be. Like intuitively, like I know like there is a user object in my domain. I know there's a user. I know some people are allowed access to some part, some user and not others. But how do I like now take this very simple idea that I have and like make sense of my APIs? But yeah.
Yep, yep. No. So I think to abstract out kind of what a stack is looking like, right? We're saying that instead of accessing API endpoints, what if we had an entity layer and we could access the entity layer with a query language? And this is just a very different way. I mean, it's not a very different way. It's perhaps a way where a lot of mature API um, uh, uh, implementations also maybe sort of start to look like, or start to get a lot more standardized, right? But it feels like entities that are then being accessed with a query language that talk to whatever system that you have on the back is is one kind of really good building block that allows for just higher accuracy on the fly data retrieval that might be required, or data operations that are required for an AI application. And that's kind of one piece to it. The the second piece to it that is also critical, which we kind of noticed, is that, and this is kind of to for all of you folks who might be saying, uh, sure, but like, how much can you do with SQL, right? Like you can't really like, not everything is possible in a query language. You're restricted by that query language itself. And then it turns out that you want to do a bunch of interesting things in the query language. It feels like the query language then starts to explode and it's not useful anymore. If you folks think of SQL for BI, where you have a complicated report that needs to be built, and I tell you, hey, you have to build this like really complicated report in like one SQL query. It's challenging. And again, it's not about SQL, it could be any other query language, but like uh, that then also becomes restrictive, right? So there is this kind of need to be able to compose data on the fly. The challenge here in what we've noticed, and I'm sure you've noticed as you've been building AI assistants and agents, is that you've noticed that like LLMs can't process data accurately if it's just in context, right? They don't really understand like a data structure. So if you paste a hunk of JSON in your prompt, the LLM is processing that as a sequence of tokens. There isn't really an inherent understanding of it being JSON. Maybe it's not required if it's small JSON or depending on the operations that you're doing. But if you are doing structured operations, it's going to hurt. Like if you give it a bulk of JSON and you say, give me the 10th, on the 10th object, do something, maybe it works, maybe it doesn't. I mean, we've seen the strawberry example, right? You give it strawberry and you ask it to count the number of hours and it screws up and it doesn't work, right? It says there's 2 hours in strawberry or whatever. And then sometimes it works, sometimes it doesn't work. But this this accurate processing and operating on data or composing data on the fly, doing that in context is hard, right? And any task that requires orchestration of many bits of data starts becoming increasingly inaccurate, right? So if I say fetch data from X and then do Y, and then for each element in Y, transform it to get Z, and then analyze that output finally, right? And this is the bit that the LM is going to be great at, or generate something, right? And these are the bits that are kind of more orchestration bits, right? This bit can start to become inaccurate. Abhinav, like from like an intuition of understanding like how or like why LMs are able to do this or not able to do this, how would you help us think about this?
Yeah, so taking that analogy of like LLMs being more like humans than software, it's like if I have to like get data from somewhere and pass it somewhere else, I do not go and like look at the data, try to remember it, go manually type it somewhere else. I have a control like control C, control V, right? Like LLMs don't have copy paste, right? They have to literally like remember what came and then try and reproduce it as is, which is where like the fundamental source of uh, inaccuracy lies. Yeah, so like inability to like refer to data that already existed somewhere instead of just having to use their context, their working memory to go and reproduce it as best as they can.
Yep, yep. No, that and I think that that's kind of contributes to this kind of inaccuracy in being able to do sophisticated tasks as well, right? And so one of the things that we've been kind of thinking about is what if we could create and execute what I'm calling cognitive programs on the fly, which means that instead of the LLM doing a thing, what if the LLM writes an algorithm to do a thing and then runs the algorithm, right? So if the LLMs kind of work at a level that is more meta, the data orchestration tasks start to become safe, right? And I think again with the strawberry example, right? It's like if you say count the number of hours in strawberry, but instead you say use Python, right, to count the number of hours in strawberry, it's accurate. It's accurate 100% of the times, right? Like, well, not 100% of the times. It might hallucinate the Python program that you're writing, right? But like suddenly it goes up from like it maybe works to yeah, this works. Like you're confident it works the way that you'd be confident like a colleague is going to give you the right answer to that question, right? This I think is interesting because LLMs are also getting really good at writing scripts and they're continuously getting better, right? Like we know that when we're writing code, LLMs are helping us write code and they're getting better and better. Like where we were 2 years ago to 1 year ago to today just feels insanely good, right? And so instead of having the LM do something, if you can ask the LM to write an algorithm and then run the algorithm, meaning a program or a script to do something, I think suddenly it becomes safe, right? So instead of um, when we want to kind of find the highest paying customer, being able to uh, process that in code, right? Uh, if you have a set of customers that is say like 10,000 lines of JSON, you know that you're going to get a much more accurate result if the LLM were to write code and execute that code to solve this problem, as opposed to trying to solve this problem in context. When you try to paste those 10,000 lines of JSON into the prompt and ask the LLM to say, find the highest paying customer, right? Um, Another kind of problem or interesting thing here with this ability to write programs is that we often need to interleave these data tasks with the LLM tasks, and that's the whole point of what an AI application needs to do on the fly, right? And that's kind of this piece, right, where suppose, for example, my problem was not just to find the highest paying customer, but it was to find the highest paying customer and then build a profile by guessing their profile based on their recent purchases, right? And so this is the bit that the LLM again is really good at if it can fetch the right data and solve that problem. But you need to kind of interleave these tasks, right? We want to repeat this across 1,000 highest paying customers. So you want to do a program to solve this problem, and then you want the LLM to solve this part of the problem, and then you want to repeat this across like 1,000 paying customers, and that's the thing that we want to do. Eh, this building block is missing, right? Like this building block doesn't exist. And just to kind of give you folks what a cognitive program might look like, right? I fetch comments and then I analyze the sentiment of each comment, and then I look at the total positive and negative content, and then I summarize I summarize all of the comments as well in an unstructured way. I pick up all of the comments and I do just like language summary of it, and then I return the overall sentiment and summary. right? This is what I would call a cognitive program, right? This is an interesting way to achieve or to solve a problem because we're kind of interleaving structured data tasks with the unstructured LLM tasks. Abhinav, anything you want to add here before we move on to showing some of this in action?
No, not much. I think like this is a pretty like it's a little bit like a uh, sort of a mindfuck type of an idea to think about. We're not used to like like thinking meta and getting LLMs to think meta. And so like I think a demo will probably like do more justice than anything I said. So I think let's jump in.
That sounds awesome. And just for folks to take a look at kind of what this stack is looking like, what we're essentially saying is, here you have an AI application. You kind of have this layer that does this kind of cognitive program execution that then relies on some kind of query language to retrieve data. And that is what this stack looks like, which is very different from the way that we just traditionally think about backend APIs, right? Like it just is more fundamental. It's using the data entities at kind of a more fundamental level and the methods at a more fundamental level and providing kind of more unconstrained access to it, but at the same time providing a safe, secure sandbox to be able to run sophisticated cognitive programs that are created on the fly to be able to do this. And this is a huge shift. And the best way to talk through that is to take a look at some of these ideas in action and see what that looks like. So let me kind of take let me start off with a few demos here on my end. We were getting rate limited earlier today, and so we've recorded a few things, but we'll take a look at that and maybe we'll have time for a quick live demo as well, where we can see some of this live in action. So here, this is an example of an AI assistant that is talking to kind of a sample control plane data for our product for Hasura Cloud. Just think of it like a SaaS product. It's like it's your customer billing kind of data. And what we kind of want to take a look at is uh, what kind of acting on that data would look like with an AI assistant that kind of had these layers of execution where you could create cognitive programs on the fly and retrieve data in a particular way with a query language. And again, we're not talking about a SQL database here. We're talking about access to that domain, right? Um, and so what we kind of start off here with is which user has generated the most revenue and look at invoices to get a sense of, where that's most amount of revenue is coming from. And and then what we notice is that the assistant starts to write um, a program to fetch this information, right? So it says, let's query the invoice table, let's join the information with the user's table to get the user's details, and let's order the results by total revenue. So what we've done in the background here is that we've abstracted the entire domain as a SQL layer. We fed in the SQL schema to the assistant as a tool, and the second part of the tool is also a Python execution engine where it can where it can write programs to do both data retrieval and execute that, right? And so and this tool is what we call Patra. And this tool is what we give to the assistant. And so now what the assistant does is it kind of writes this Python program, and you can see that it starts to try and execute this Python program, right? And at first glance, you feel like that's interesting, right? Like, I mean, I think if we write this program, it feels like it's the right program. Let's see what happens. It runs and it says there is no results. Like, this is classic, like, oops, we thought this would work. And it didn't work, right? And so now what starts to happen is this kind of experimentation of auto healing and saying, all right, let's get the assistant to dynamically kind of figure out the right program here, right? And so it says no revenue data found. And then, like LLMs, I think broadly are nice. And when LLMs become impolite, I think it'll signal another kind of end of the world. But the LLM nicely says that it's apologizing for this result. And it starts to now really get into experimenting with what really the structure of entities are and uh, and what the data inside those entities are to see if they contain any records, like why is there no data here, right? So then it kind of creates a program to check those tables individually, right? And again, these tables are tables at the kind of abstraction layer. Underneath it, these are whatever, right? Like it's not even a SQL database, right? It could be anything. Um, it we're going to these various things, and we're trying to get a sense of what is actually happening in the data, and we're getting responses. So we know that we have invoice data, we know that we have invoice item data, and we know that and this particular query ought to work, right? So it kind of goes to the next step of self-healing, where we know that we have data in these tables or in these entities. And so it then seems like the previous query that we were trying to make, the problem is likely to the join condition. And by the way, this is I think we're using Anthropic Sonnet here. Am I right, Abhinav?
Yeah, sound.
This is just vanilla how good Sonnet is, right? This is no training, no fine tuning, nothing. It's just working. Like we gave it our domain modeled as a query language and entities, and this is just it working normally, right? um Out of the box, right, in like 5 minutes of setup. And so it says, well, the issue was probably because of the join condition, and then it starts to like suss that out, and then it creates kind of um an interesting, it figures out that this join condition is a problem. It starts to validate that idea, um, and kind of gets to this point where, scroll ahead a little bit, right? It further investigates like the different kinds of joins that are happening. And now to get better at that investigation, it now actually goes and introspects those entities. So now it's going and it's hitting the information schema, the catalog, for more granular information about what's actually happening. And again, it writes a program to get more granular information about the underlying entities, what is happening inside those entities, right? Um, Gets that data to see why the join condition is not working. So it's debugging the join conditions. Like, let me fetch data here, let me fetch data here, and let's see what is wrong with these join conditions that aren't right, right? And this then helps it figure out that ultimately it was joining on it looks at this data structure, and you look at this data structure, it's a API data structure. It's not coming from a database, and and because of this, it figures out the root cause of the problem, that customer ID does not correspond to ID. And this is a problem that I'm sure all of you have in the real world, where you have just bad keys that are not good join keys, right? And figuring out the right join key is a pain, right? And if you don't have that, and it uses the right join key, and then it runs this query, and the query executes successfully, right? And this results in an answer, right? So that kind of is a process where it goes through from start to finish, no human intervention, solving this entire problem step by step and getting to a result. The way to now improve this and prevent this from happening again, by the way, is to just create a relationship, is to create an actual quote unquote foreign key in the schema, which is not actually a foreign key because these two entities could be coming from wherever. So it's not actually referential integrity foreign key, but to create a foreign key between these two systems that better describe what field maps to what field. And the next time, this just works more automatically, doesn't go through this process. It won't go through this process of trying to figure out, trying to debug this condition. And so our data layer, our semantic layer will get better, and then this will work better the second time around. So this is kind of one example of kind of this auto-healing behavior that can happen when we start to kind of use a cognitive program construct and um, a query language, as opposed to kind of trying to do something either directly against the database, or trying to use API endpoints, or not use a programming language, trying to do everything in context instead. I'm going to switch over to Abhinav and let you take a look at maybe trying out some of these a little more live with the UI, where we can maybe take a look at acting on some actions where you're not just kind of consuming data, but you're also interacting with that real-time data and perhaps making modifications to your system on the fly as well. So with that, Abhinav, let me just hand it off to you and see if we can do something live, and hopefully we were not get rate limited.
Yeah, Anthropic has been acting up so much today and yesterday. Let's see. You guys see this? Awesome.
Yep.
Cool. Um, because this can take actions for me, let me just try to send myself some money. Why not? So issue $20 in credits to for the latest project.
And so just to kind of maybe walk through the example here in the background, right? So this is, again, we're kind of talking to our Hasura Cloud systems in the background. Hasura Cloud is this notion of a project and a user. And what Abhinav is doing here is asking to issue $20 for the latest project.
So as you can see, it like first try to get all the information about myself, like what's my user ID, what projects do I have, what's the latest one, and so on. And then um, yeah, and then now it decided that okay, now I see this like stored procedure that I can use to actually execute a mutation, and it's tried to call it made a mistake in the syntax, and so it's trying again, and this is what it's trying to do now. So it's saying like, I want to issue credits or refund. $20 is the amount. This is the email. This is the owner ID and the project ID. But since it's a mutation, we can't just trust the LLM to just go and change state willy-nilly. So what we have done is like since our semantic layer understands which functions are actually mutating and which functions are not mutating, it can just like interrupt and block them while they're executing and throw it back to the user for confirmation, like, hey, are you sure you want this to go through? And yes, I would very much like the money. So I approve it. And then like the execution of the Python program continues. And it says that, hey, I have issued stuff and here is some information about like what got issued. Um, Interesting thing to note about these, like the artifact it's creating to show data uh, in a special UX, they are coming like directly from the program, which means like they have not been like tainted by LLM context. Like it's sort of 100% reliable in like what data actually gets retrieved from the database, what actions actually take place. Those are the only ones that will make it here. So you're like sort of guaranteed to guarantee that like these IDs, for example, didn't like get lost in translation. And you can see that from the Python program also, which is like once it's issued a SQL query, got the response, it's gonna go create an artifact and put everything in there. So yeah, that's that's like a demo for how you can take like real world actions and not just like make queries and get data, but actually use it to perform workflows and perform tasks and get like productive in general. Um,
Abhinav, I think what you mentioned about like the data artifact point is interesting. It's a little bit subtle.
yeah.
Is there another example that you could take to show perhaps maybe
Mhm.
some of these artifacts being used on the fly? Maybe we create an artifact
Mhm.
you know, if you have something in mind.
Yeah, so let's I say do like show me uh, the I don't know most recently created projects. So you can see it fetched the data and created a list of all the most recently created projects. Um, um, but now let's say I see that let's say I want like more information about this one. So I say like uh, uh, show me more information about the creator of the fourth one.
Very interesting. So I think like the core point here is that we're not taking data and we're not putting it in context. It's not a part of our LLM chat context, which means that like that thread is kind of protected from the noise, potential noise that can happen, or pollution of context that can happen as you're working on tasks.
Yeah, exactly. And so you can see like it can go and start like producing these artifacts, store them for like future reference as well. So this time, like it knows that it created an artifact with all this data. It can't see it in context, but it knows that it can write some code to go ahead and like fetch that artifact and read up and then do further processing on it. So that's the basic idea that like no matter how much amount of data you're retrieving or manipulating over, and like especially like typically you would want to go through workflows like step by step. Nobody's just has like the exact query they want to type in that's gonna do the right action. So you typically go step by step, like ask a series of questions with follow-up questions, which like builds on top of what you've already done. And this gives it the ability to like not lose context on what's happening. Like it doesn't pollute the context with all kinds of data. It just only has the metadata and information about like what's it been doing, which just makes this process like very reliable.
And I think there are pretty like serious, I think, considerations here also. If I can just take over sharing my
Yeah.
screen for a second. There are interesting implications here as well because um, like on performance, for example, right? Because oftentimes when you're operating on stuff, right? Maybe maybe you are fetching a very large amount of information that you don't want to fetch again and again. You want to kind of keep that artifact and re-reference that artifact. And I know we've used the word artifacts, but these seem very different. There's a very different way of using artifacts from what we've seen with on Claude.ai on Anthropic's assistant, where they're kind of taking the artifact and they're printing that in memory. So how has that been in terms of like the experience to kind of build this layer, Abhinav? Like, what were kind of the pros and cons of having an artifact that is not actually used in the context, but an artifact that is referenced, that is made available for the future? What are the pros and cons of the approach here?
Yeah, so like the obvious pro is like you can deal with a lot of bulk data reliably, and it doesn't pollute the context. The cons you have is that like because you cannot see the data in its entirety, you're not sure like what to do next, and like again like it can lead to hallucinations and whatnot. So like the approach we take is like try to like balance it, like uh, let the LLM take a peek at the data, which is what humans would typically do, right? I'm not going to go look at my entire data. I'll look at a few rows and see like, okay, this is generally the right data that I was expecting. And so that's what we let the LLM do. Let it examine like the artifact by default for a couple of rows. If it wants to do more examination, it can always print it out in code. And so yeah, that's the general idea
Got it.
behind it.
Got it. Got it. I just want to take another quick demo before we move towards wrapping up. Right? Is also kind of integrating this control plane kind of data that we have here with support tickets and support data for doing something slightly different, which is to say, look at kind of the support tickets by company A and tell me why they might have churned here, right? And in this case, what we're really doing is we're we're using kind of this query language API on top of Zendesk, and that's kind of giving us a analysis of what the different kinds of issues are, um, and 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 you can see it's using kind of like a cognitive programming construct here to classify and to understand what the nature of the problem is, and then gives me a summary that talks about kind of what these different issues are. They face performance issues or technical issues or reliability issues or whatever it is, or billing and contract issues, right? Um, and then I can again act on it, right? Like for example, I could even get back to the customer here with a particular thing. And any point during this workflow, these artifacts are available for examination, right? So these are the actual artifacts that are used. And as a human, I can also go and look at this. Now, typically, I think like as we kind of actually see build assistants and agents here, we might not necessarily be looking at the Python program code. You're more kind of looking at the tasks, and maybe you're looking and validating the output of the task, and you're probably going to only like start to really look at the program or validate the program. And I don't think that's necessarily a natural part of the workflow. Um, I this the work that we've done here is, um, and we'll paste this link here, but this the data layer, the cognitive programming kind of uh, layer that can execute these programs dynamically, safely in user context. And this the kind of authorization piece is something that we've been working on. It's available now for people to set up and try out and get and set up inside their organizations. So if you want a personalized setup for your team or your organization, please reach out to us, and our field team will help you kind of set this data layer up and set this kind of program execution layer up. And this can work with any LLM that you have. And of course, you'll have to do a little bit of iteration here to see how you're going to do some of the data verification stuff and stuff like that. But there's a base design pattern that you can start to use, but the data layer will exist for you. And so do feel free to reach out if you want to set that up and play around with this. And otherwise, feel free to reach out to us for any questions. We couldn't take too many audience questions, but we did weave that into the conversation, so hopefully most of them got answered. Please
Tanmai,
feel free to
we
reach
can
out to
answer
us.
a few questions if you want right now.
Oh, awesome, cool. So I think one of the questions that we had here was, um, let me just bring that up. Give me a second. Perfect. Um, cool. I think one of the questions was whether we have an agentic framework at play here in how that autocorrect was happening. So, Abhinav, maybe you want to talk a little bit about kind of how that self-healing autocorrection piece was set up.
Yeah, there is like I don't want to go and call it an agentic framework because like that sounds like more complicated than it needs to be. But it's using like just vanilla tool calling with a single tool, and that's literally the end of it. So it has a tool which it can invoke to execute Python code. Otherwise, it just runs in a normal assistant chat loop, where if a tool call request comes in, we execute the tool, give the output back to the LLM, and it goes on from there. So it's as simple as that. Like it's our semantic layer, which lets us create like sensible SQL schemas and expose like your data sources as SQL to a database. Plus the ability to like to have a Python execution sandbox in there, which LLM can use to like execute Python code. Just this alone makes it like automatically makes it a very powerful agentic framework. There's like no fancy like, oh, I model a graph of my agents and it can walk edges and whatnot. Like none of that is happening. It's just like much more straightforward. It's like doing the hard engineering work on the semantic layer and the Python execution side is like what is like making the AI part of it as simple as it can be.
I think that's a very interesting idea, and I want to kind of double down that. So I just saw internal messages, and I realized that we were getting rate limited by Anthropic in the morning, and so for the demo, Abhinav actually switched over to OpenAI instead, right? And that's it. Like that, it works. There is no we didn't know there was no fine tuning or excessive prompt engineering that was required to get this to work because it's already good enough to do this. If if we're able to kind of shift where we are putting in the engineering investment into kind of creating that query engine and the semantic layer and providing kind of a cognitive program constructs and a way to execute that, it automatically starts to work. Um, Let me take a quick look at any other questions here. All right, let me see. Sorry, just give me a second. So kind of just talking about different kinds of data was, I think, the other is like an interesting question that I think worth kind of digging into a little bit. So this can be kind of any data source. We didn't do some of those demos today, but if you're interested in kind of setting this up or building this yourself, right? Like in how you think about it, this can be anything. So this could be an ESP, it could be an ERP, it could be there's kind of a way that we think about how connectors need to be built to bring those data sources into kind of a semantic query layer. Um, and so so that can be done. It works with files. We can even read unstructured data, and so we can work with that as well. And so that should handle all kinds of data. But that's what we have time for today. Thank you so much, folks. Feel free to reach out to us and do check us out here. And we can help you get set up with something that you have or chat real-time data as well.
Thanks, folks.